In this video, we're going to talk about the Chrysler 446 pack setup and choke operation. Specifically, choke operation with no intake manifold heat at the choke well. Either head's been replaced, no crossover passages, intake manifold has been used that has crossover ports blocked intentionally, headers, exhaust manifolds without heat riser valves that were all part of that original design to route heat up under the intake manifold and heat that divorced choke spring. By the way, this particular divorced choke system was used extensively through Chrysler engines in this time period, and they all depended upon exhaust manifold heat for them to function correctly. Without manifold heat, we supply electrical heat to that spring, very similar to what Chrysler did in 1973 and up. As a matter of fact, we're going to use some components based on later heated choke spring assemblies. This is an original 6-pack divorced choke, no heat, no added heat rather. And this is a modified 6-pack choke that has some components from a later electrically assisted divorce choke. So the remainder of the video shows some tips on how to resolve this issue for those who understand the issue and are looking for alternative ways to resolve it. If you're of the mindset that you don't need a functioning choke, or that your car works fine without a choke, or your choke's been detuned basically to operate without heat, this is probably not the right video for you. Modifying a Chrysler 6-pack divorced choke to be electrically heated. This step involves a later divorce choke with a heating element built into it, 1973 and up. Typically, what you're after is the version with the wire extending through the top of it. There's a few other versions out there where they come out the side. This is not going to work for this modification. The ones with wire extending through the top. Could be a thermoquad, could be a Holley 2-barrel. Rods are a little bit different, but the basic construction is the same. We're after some of these parts, and we're going to trim this mounting bracket in something that resembles this. You're going to work on that to refine it for a better fit. Basically, what we're going to do is when you get done with this, you're going to remove. First step on the 6-pack choke is to take the parts off of here, and this little standoff for the pivot comes off. There's a couple of small little spot welds in there that hold to the cover. You can grind them down on the inside here, and this bracket will come out there, and the top of this will look just fine. And you're going to create a hole for your wire. You're going to fit the piece that you've cut off of this underneath, pop rivet it together. You're going to use the rod bracket from the later version. You're going to use the 6-pack spring that was on your original 6-pack spring. You want that calibration. And the rod, of course. And you'll wind up with something like this. Fits into the well. Works like the later version. And that should resolve issues where there's no manifold heat. This little heating element pulls quite a bit of current. This is like a 2 amp when it's cold. When it gets warmer, it'll drop down to about 1 amp, but it's still quite a bit of current to be running all the time on your ignition circuit. The factory addressed that with the choke control timer, electromechanical device that applied current to the heating element for the first few minutes of run up to try to get the choke to come off sooner. Emissions there, trying to get it lean. After 5 minutes or so, these should open and kill the current to the heating element. There was a two-stage version that had a resistor mounted to the side of it. We're going to do kind of the same thing here. We'll get into that in just a sec. The original timer was electromechanical. The points would burn up, stick together, or they would build so much resistance that it would stop current flow to this thing. These things failed so much so that these were actually a tune-up item at the dealers I worked at. Get your spark plugs and your wires and everything else, and they throw a controller at you. There was a later version of this that was an attempt to go semiconductor, little round button, same kind of mounting bracket, same terminals. Those didn't last any longer than these guys. More recently, I've tried a couple of these guys NOS here in the last probably 10 years or so, and they do the same thing. They only last a month or two and then they fail. So I went a different route. This is my original choke control timer based on a solid state LM555 timing chip. Little simple guy. Looks something like this. Works well. You have to fumble around with the resistance values and the capacitor values to get the timing you're looking for. So there's a little bit of experimentation with this to get it to work the way you want. More recently, you can get these little timer boards, Amazon, for 15 bucks or so. A little more precise control over timing. You dial in the jumper terminals for a certain range, and you can kind of tweak it with a little pot there. You input in your ignition circuit on one side. There's a little built-in relay here. It's rated at 10 amps, but I don't trust it for the heating element. Some of these little traces that are on the back side on that secondary part of that relay are not going to handle 10 amps. So what I do is I drive a regular external relay with this little built-in timer. These things are not watertight, by the way, so if you're doing something under the hood, you need to stick it in an enclosure or something, or mount it up inside the car somewhere on the inside. But you use this timer to control a conventional relay. I've been using these little micro guys here for the last few years, about half the size of a conventional Bosch. But again, the intent is to reduce the current consumed by this heating element after the car's warmed up. 8 minutes or so is all it needs. Relays kick out. The bypass resistor is on the secondary side of these contacts, so when this opens, the current is routed through the resistor, reduces this current draw in about half. It's down to about a half an amp. It's enough just to make sure that this doesn't cool off. I should be looking at this other one actually. I found that without any current at all to this on an engine that doesn't have any crossover heat at all, the manifold, this guy would cool off a little bit and start to want to apply the choke a tad. So the resistor allows a little bit of heat going on here through the remainder of the run cycle. That was enough to keep this, make sure the spring was always relaxed while the engine was running without exhaust manifold heat at the choke well. That about covers it for that. Now for a little demonstration on how the system works. Let's start out with a temperature check on that spring. 78 degrees, cold, nothing going on there. We're going to power up our ignition system at 12:30. 13.3 volts. Started out with almost a 2 amp draw on that heating element. It's starting to drop a little bit. We'll see how long this timer runs before that relay opens up. Okay, 5 minutes in. Our spring has relaxed quite a bit. At 8 minutes here, our choke spring is relaxed almost completely. Okay, the relay just released at 11 minutes for this particular timer. Our voltage has dropped. We're now routing our current flow for the heating element is now routing through the 10 ohm 10 watt resistor. Dropped our voltage down to 8 volts and a little over half amp for a current draw for the remainder of the ignition run cycle. You'll also notice the choke is completely off. The spring is completely relaxed. We'll watch it for a second longer here just to see what the current does. It's like it's creeping back up a little bit. But that's how it works. And that's the demonstration. Let's see what a cold startup looks like on this choke system. This is way cold. This car hasn't been started in 3 months probably. We'll do a little priming of the fuel system.